All right, so today we're going to talk about how to measure data. Now, when it comes to data analytics, it's good to have data, but we would have to, when we talk about data, it's good to have some kind of numerical values that we can use. And being able to describe our data is part of our descriptive analytics component of this course. So we have different measurements of data, and right now we'll talk about measures of location. And all of these measures of location you have heard about in the past. Most likely you've heard about them in some of your high school mathematics, and if you're taking statistics courses right now, you've heard about these too. So I'm not going to go over each of these in any kind of great amount of detail. I'm just going to talk about them briefly, and I'll demonstrate them in Excel and see how they apply in the areas of data analytics. So the first thing is arithmetic mean, or mean, which is nothing more than the average for a variable, right? So when we have our data sets, and we have our x's, and we have our y's, and we have all of our values, x represents a variable, and it's the average of all of these, right? And so most of you are familiar with how to calculate average. Basically, you have value 1, value 2, and value I, which is the last variable for an n number of observations. So if you have 10 observations, this is the 10th variable for the 10th observation. So you add them all together, you divide by the number of observations, which is mathematically represented here, and there you have your average or mean. This is an example of a data set we're going to use, and I just want to point out a couple things. This is very small, and when I work through the example, if you have the PowerPoint available, you can simply copy and paste these numbers into an Excel spreadsheet and work along with me. But this is data based on home sales in Cincinnati, Ohio, or a suburb in Cincinnati, Ohio. It's not a very critical data set, but if you want to know where I'm getting my information, this is what we're going to be talking about. So if we want to compute the mean, what we can do is add all the variables together, divide it by the number of observations, and then we get a value 219,937 and 50 cents. Now, let me go back just so that we know this was the average of all of these values. All right, so now we're going to talk about a median. Again, median is nothing more than the value in the middle. And but it's important to know two distinctions when it comes to calculating your median. You have calculating your median when there's an odd number of observations, and then when there's an even number of observations. So for the odd, it's obviously the middle, and for the even, it is for the average of the two. So let's kind of take a look at that. Here is an example data set. And if we sort it here from lowest to greatest, looking at the value in the middle, that is 46. All right. Now, if we were to add another value here to this data set, let's say that value is 46. Well, and then when we resorted it, it would probably end up, let's just say, right about here. So we'd have 32, 42, 46, 46, and then our new value 46 would rest right there, and then 54. And then since it would make that an even number data set, we would have to take the two values in the middle and average them, and the average of 46 plus 46 is still 46, so that would be the median for an even number of data points. So here's the, using our data set, here's the illustration. So here's all those home prices that we saw previously. And if this is an even number, remember we had 12. So it looks for the two that occurred in the middle. And this is already pre-sorted. So those two values are right here. Okay. Looks for the average, and that is 203,750. All right. Then we're going to talk about mode, and I'm going to show you a little bit of things here when we get to the Excel spreadsheet. Mode is nothing more than the value that occurs most frequently, and looking at this small data set, That's obviously 46, right? But one of the things about mode, a lot of times when we deal with distributions, we deal with a bell curve distribution, right? And then would be a single mode because you only see basically one camel hump. That might be a kind of a way of looking at this. But occasionally what happens is that you actually might see a distribution that will have one large, maybe another smaller camel hump. And then since this has more than one hump or one, it's considered multimodal. And specifically, if it only has two humps, it will be bimodal. Right? That helps represents the mode. I mean, obviously, if there was another hump over here, that would be, multimodal for sure, and not bimodal. So usually you look at histograms or just data distributions in order to be able to see this, and that's kind of how we can evaluate it. But numerically, we have means to do this in Excel as well. So for your reference, these will be the formulas that I'm going to demonstrate on how to use. And then we'll be able to calculate these values. And if you look earlier in the slides, you can see this is what we're going to calculate. I know that's meaningless here, so that's why I think it's more valuable for us to demonstrate it. So let's go back here to Excel. Here is the data set. And so basically we'll type in average, and we're going to select the cells and close our parentheses, and that's how we calculate average. Notice that I have my formatting, so that way the numbers kind of roll off, and that's okay. I'm not really worried about it. I mean, if I wanted to, I could increase the decimal and see that 50th percentile place. All right, median. Median, select the range. Boom. Mode. Now this is very interesting on how this multi-mode works. This is why I wanted to demonstrate it, because it can be a little confusing for some. So what we'll do is we're going to select both cells where we want mode 1 and mode 2 to be. Okay, so they're both selected. Come up here to our formula box, type equal, type mode, and we want multi. Hit tab. Now notice I've still selected both of these, but I'm going to go ahead and select the range of my data where I want my mode to be. And here is the trick. I need to hold down my control button. For you Mac users, it might be command. So control, shift. I'm holding these down at the same time, and then I hit the enter button. And by doing that, I'm able to get this bracketed style or array-based formula in play. So that's how we calculate multi-mode stuff. And so the idea here is that there'll be 138 would be the most occurring, and then there's a second mode. The second most occurring would be around 254, and so that's what that means. Okay. So let's go back here. What I'm going to do, I'm not going to be concerned about geometric mean in a greater scheme of things, but geometric mean is basically looking at financial data, specifically for growth rates. And so here's a data set, and here is the calculation. The easiest thing for me to do is to show you how this is done in Excel. So let's go back to Excel. I have my growth factor data, and what we want to do is calculate the geometric mean. So basically what we're looking at is that we have a return value of this percentage amount, and then we have a growth factor here. And the geometric mean is nothing more than using the geomean formula, select the values, and then close your parentheses and hit enter. Now, because it's at 102.93%, we have to subtract that from 1. Well, 1 minus that, excuse me, geomean minus 1, and then we get the actual rate of 2.93%. Okay, and this is the growth rate. Okay, if this is the growth factor on a financial yield, geometric mean represents the growth rate.